Hello. Our project looked at whether high school students' attitudes towards drinking tap water could change if they tasted water from different sources or saw real quality data. We compared tapped, filtered, and spring water and used pre and post surveys to measure changes. Overall, most students already felt okay drinking tap water, so we didn't see big attitude shifts. Across the world, bottled water use keeps increasing. This is a problem because plastic bottles take hundreds of years to break down, and most never get recycled. Even though people know plastic bottles are bad for the environment, studies show that they prefer bottled water. That made us wonder whether students here feel the same way. Our goal was to find out what our student population thinks about drinking tap water. And if students did have negative attitudes, we wanted to see whether tasting different water samples or seeing water quality data might change their minds. We collected about 1.8 liters of water from 3 sources: a regular drinking fountain, a filtered fountain, and a spring water bottle from a major brand. All samples were stored in identical metal bottles. These photos are the metal bottles and cups we used when preparing the water samples for tasting. We measured the pH and conductivity of each sample using calibrated probes connected to a Raspberry Pi. All samples were tested before the experiment so we could share accurate data with participants. pH tells us how acidic or basic water is. The safe range for drinking water is between 6.5 and 8.5. Below 7 means acidic. Some metals become more harmful when water is too acidic.
Conductivity measures the amount of dissolved minerals or impurities in water. U.S. drinking water usually falls between 50 and 1500 microsiemens per centimeter. Higher numbers can indicate more impurities. We collected data throughout October and November by asking students during lunch. 31 students participated, with 2 students from each grade in most groups. Ages range from 14 to 18. All participants took the same pre-survey and post-survey. We focused on one key question: would you consider drinking tap water? This helped us measure whether attitudes changed. The control group took the survey, did a short word search, and took the survey again. This helped us see whether just taking a survey twice would affect responses. In this condition, students tasted all 3 water samples, learned which was which, and then took the post-survey. We used this to measure whether tasting the water alone changed attitudes. In this condition, students didn't taste the water. Instead, they reviewed the pH and conductivity results for each water source before completing the post-survey. This let us test whether data alone changed attitudes. This group tasted all 3 samples and saw the water quality data. This tested whether combining both experiences would have the biggest effect.
We used the McNair's test, which compared the yes or no data responses from before and after each condition. This is calculated by using Python code, as shown in the slide. None of the conditions showed a statistically significant change in attitude. For conditions 1, 2, and 4, the p-value was 1.000. For condition 3, it was 0.250. All of these results show no significant treatment effect. This actually surprised us because the literature shows that people usually prefer bottled water, but in our study, only 4 out of 31 students had negative attitudes towards drinking tap water to begin with. Also, all water samples met safety guidelines. Our data suggests that linking bottled water doesn't necessarily mean students dislike tap water, since most students here already view tap water positively. A campus campaign to reduce bottled water could work. We recommend reminding students about the environmental impact of single-use bottles, offering reusable bottle options, and helping students understand global water issues. These are the sources that helped guide our research.